Next we have graphical representation of motion. Okay, graphical representation of motion. Now this here we have graph of object at rest. Let's say you are you are you walk, you are here, you walk a distance of 15 meter. After that you reach here at 9 a.m. you were here, and 9:15 you reaches here. After 9:15, after 9:15 you don't move, you are here till 9:30, till 3 o'clock you are here. So what is the distance you have traveled? Distance is 15 meter. Let's say from 9:15 to 3 a.m. What is your motion? Motion is, you are 9:15 to 3 a.m. you are at rest, right? So what is the distance? Distance is, let's say you have traveled 15 meter. 15 meter, let's say. From there you don't change. When it reaches, let's say 1 minute, you don't change. 2 minute, you don't change. 3 minute, you don't change. 4 minute, you are still there, you are not moving. Okay, that means you are object at rest. For the object at rest, so this is the example of object at rest. This is the graph. Okay, so what is this? This is distance. What is this? This is time. Okay, distance, time. This is how you draw a graph. This is the graph between distance and time. Distance is not changing, distance is not changing, distance is constant. If distance is constant, that means object is at rest. Okay, distance is not changing, that means object is at rest. This is the graph. Okay, let's say you started moving. Let's say 9, let's say you are at 9 a.m. you don't clever, you are at home. Okay, let's say 9:10. Okay, you traveled 2 kilometer. Let's say 9:20. Okay, you traveled 6 kilometer. Okay, let's say 9:30, you traveled 8 kilometer. Okay, now what is this? What is this? So you can look here, what is happening here. Let me draw a graph. 6 now that means this is 9:20. Let me make it to be 4 kilometer. Let me make this to be 4 kilometer, and let's say this is 6 kilometer, like this. So what is happening is time changes. Look here, time is 10 minute, here also 10 minute, here also 10 minute. Distance is here 2 kilometer, here 2 kilometer, here 2 kilometer. So if I draw a graph, how to draw a graph? You know how to draw a graph, right? Make one line like this, make another line like this. Okay, this is my x-axis, this is my x-axis, this is my y-axis. So this y, this side is, this is distance, this is time. Time, let me write down in minute. So let's say time in minute, let's say this is 10 minute, let's say this is 20, this is 30. Okay, and distance is let's say this distance, this one is, this is 2, this is 4, this is 6. Okay, so let me write down the distance this side. 2 4 6, 2 4 6. Now at 10, at 0 it was 0. At 10, when it was 10 second, it was 9:10, right? 10 minute, it is 2 kilometers. So I will write down here. When it was 20 minutes, it was 4 kilometers. When it was 30, it was 6 kilometers. So if I draw this line straight, I'll get a very straight line like this. Okay, so this is my graph. Similarly, like that, this is the graph they've shown. Okay, so here you can see 4 kilometer at some distance here and some distance here like this. It is changing equally, right? If it is like 8 minute, it is 2 kilometer. Then this must be 16 minute, it is 4 kilometer. And 24 minute, okay, or this is 24, it is 6 kilometer like this. This is for 24. So the graph is little bit not that correctly drawn in a textbook. Okay, it must be like how I've drawn like this: equal distance in equal time. So this is for uniform speed. This is distance time graph for uniform speed. Let's go next. Okay, let's say for non-uniform speed given, this is very easy to draw. Time is 0, distance 0, time 2, distance is 2, time 4, distance is 8, like this. So how to draw this? Same, draw one line like this and like this, two line, right? For you to make it easy, let me make like a textbook. Let's draw like this. Now let's say this is time. Time I'm giving in second. This will be distance in meter. Now time is, this is, let's say, 0 second. This will be 2 second, 4 second, 2 4 6 8. Okay, now distance in meter. Let's say this is 2 meter, 4 meter, 6 meter, 8 meter. Let me make it bigger. 8 meter, 10 meter, 12, 14, 16. Okay, 16 and so on. Now let me draw a graph. So from this point, let's say 0 means 0. If it is 0, it is 0 here. It is not 2 here. Wrongly drawn. This must be 2, 4, 6, 8, 10. So when it is 0, it is 0 this point. Now when it is 2, it is 2. When it is 2, it is 2. So a straight line will come. It will meet here. When it is 4, it is 8. When it is 4, it is 8. So 8 will go come like this and 4 will come like this. So this will be my point. When it is 6, it is 18. When it is 6, it is 18. So 18 will be some above here. Let's say there is somewhere here 18. Okay, let's say there is 18 here. They were up here, right? So it will be coming like this. It is 6 here. So 18 will be here. So if I draw in this line, I'll get like this, right? Are you getting my point? So this is for this is for non-uniform. This is increasing, this is accelerating in motion. Okay, okay. So according to this table, if I draw the graph, I have drawn this graph. This is distance time graph. Okay, for this table data. Let's go next. Next we have velocity time graph. So what is velocity time graph? The graph between velocity and time. This is time and velocity. Let's say velocity is not changing, velocity is fixed. You are driving a car and the car speed is 30 kilometer per hour and it is same, not changing. So 30 kilometer per hour, but velocity time graph is little bit different. Before, while drawing the graph, just before, what you have done? What you have done was, just before, while drawing the graph, this was distance, right? And this was time. This is distance time graph. Now we are talking about velocity. So velocity means here it will be velocity. So let's say velocity is fixed. Velocity is not changing. Okay, velocity is fixed. at what? 30 kilometer per hour. And it is not changing, it is fixed always 30 kilometer per hour. Your vehicle speed is not changing. Time changes, let's say 2 meter, 2 minute, 4 minute, 5 minute, or let's say time you are giving in hour, then 5 hours, 6 hours, 7 hour, right? 2, 3, 4, like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Time changes, but speed remains same, kilometer per hour. Speed is same. Okay, this is for uniform velocity. Okay, let's go next. Let's say for non-uniform, for correct. Okay, this is the data. How to draw the graph of this? You have to draw like this. Take, this is given in a textbook. Okay, let's say this is time. Let's say 5, or let me start by 10, 20, 30, 40, 50. This is time, time in second. This is velocity 5. Now let me start from 2. uh, 2, it's too high, so let me start from 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, okay, 60, 65, like this. Okay, now I need to draw a graph. Time is how much? 0 second. Time is 0. Time 0. Velocity also 0. Time is 10. Velocity, let's say I'm taking in meter per second. Let me take in kilometer per hour. Oh no, let me take meter per second. Fine. We take meter per second. Now time also 0. This one also 0. Time is 10. Time is 10. Velocity is 5. So 5 and 10. Time is 20. Velocity is 10. Velocity is 10 and time is 20. Velocity is 15 and time is 30. Velocity, time is 30, velocity is 15. Time is 40, velocity is 20. Time is 40, velocity is 20. So I got this. So if I join all these points, I'll get a straight line. Okay, little bit mistake maybe I have done while drawing this, but you'll get a straight line if your graph is correct enough. So you'll get the graph like this. Have you seen this? Okay, this is velocity time graph. Okay, now velocity time graph for object with uniformly decreasing with time. If the speed is decreasing, look, at 2 time 2 second, the velocity is somewhere here. This one, let's say 15. Then at 4, it comes out to be 10. At 6, it comes out to be 5. So it is decreasing. So this is for decreasing. Decreasing by equal interval. Now let's say fast, look here. Velocity is speed, right? Velocity, and this is time. In the beginning, not moving, that means rest. Now after that velocity is 0, right? This is velocity is 0. Now velocity increases uniformly, so this is acceleration. After that velocity is constant, so this is uniform velocity. Okay, after that velocity started decreasing, so decreasing velocity is negative acceleration. Okay, after this point velocity started increasing again, so acceleration again. Okay, I hope you got all these points. Let me take a graph and make you understand whatever we have done so far, so that there is no confusion left for you. Okay, so we are going to discuss about graphs. So this is the page about graphs. So there are two kind of graphs we have discussed. What are those? What are the two kind of graphs we have discussed just now? First one is graphs we have discussed two types. One was, the first one was position time graph or distance time graph, right? The first one is distance distance time graph. Another one was velocity time graph. Okay, I'll draw a single graph for both these and make you understand the things. Let me draw a graph. Let me draw a graph for this, and you'll understand everything from this particular graph. Let's say I have this. I think I need to make it thicker. Now let's say this is my distance. This is distance. And this is time. Time can be in meter, minute, it can be second, it can be hour, okay? It can be anything, okay? Distance also can be in meter, it can be in kilometer, okay? Anything. Got my point? It can be centimeter also. Now, let's say I have graph like this. Okay, and I have same graph. Let me take same graph for this one also. I have same graph, but the difference is, in this my second graph, this is my velocity and this is my time. So time can be in second also, it can be minute also, it can be hour also, whatever you get. And velocity can be meter per second, kilometer per hour, anything like this. Okay, so now let me write on A B C D E and try to understand. This is, let's say, O A B C D, O A B C D. Now let us talk about what kind of motion is this. Let's talk first about this one. What kind of motion is this? Now in this you'll see that it is traveling equal distance in equal interval. So look here, distance is equal, right? Till here it is traveling equal distance in equal interval. Let me write down 10, 20, 30, 2, 4, 6, 8, 10, 12, 14, 16, 18. Here also let me write down as same 10, 20, 30, 2, 4, 6, 8, 10, 12, 14, 16, 18. Now look here. So what is happening here? It is changing equal distance. Distance is 10, time is 2. 20, equal distance in equal time, right? So this is uniform motion. This is uniform motion, equal distance in equal time. Okay, uniform motion, equal distance in equal time, I can call it as uniform velocity. Uniform velocity. Okay, okay. Now let's come here. This is 30 kilometer per hour, and the 30 kilometer, it is fixed, right? It is not changing. Distance is not changing, so that is at rest. At rest, it's not changing, distance is fixed. Now distance is reducing. Okay, reducing, distance is coming back. Okay, that means you are going back, changing the direction. Okay, you are going back, changing the direction. Velocity is decreasing. Here it is uniform, but it is decreasing. Your distance is decreasing. It is not possible actually. This must be displacement. So for this, let me just rough, because this is for you. You will understand better in class 11 about negative things and all. So let me take only till here. I hope this is clear to you. These are the only two conditions. Okay. And third condition I can take like this. Let me take the third graph to be like this. Let's say it goes like this. So this is non-uniform motion. Now let's go to velocity time graph. In velocity time graph, this one, velocity is increasing in equal interval of time, right? This is called acceleration. What kind of acceleration? Uniform. Understand, here the same thing was uniform velocity. Here the same thing was uniform acceleration. AB fixed velocity, right? This is uniform velocity. Uniform velocity. Here it was at rest. Here it is uniform velocity. This is negative acceleration. Negative acceleration. Okay, this is positive acceleration again. Fine, I hope you understood this. Okay, this is all you need to understand about graphs. Okay, there are something about area and all. Don't worry, I'll make you understand once we do the equation.